In Bronsted Lowry theory, we identify a substance as an acid or base depending on what we see it doing in a particular reaction. The same material can be an acid or a base depending on what it is reacting with. So you have to examine the reaction every single time. Here we see phosphoric acid reacting with ammonia. We need to identify what phosphoric acid is paired with on the opposite side of reaction. So I look for a substance which differs only in the presence or absence of a hydrogen ion, an H positive, a proton. The difference between H3PO4 and H2PO4 minus is a single H positive. The H3PO4 loses or donates an H positive as it becomes H2PO4 1 negative. So this is my Bronsted Lowry acid. I have to do the same type of thing now for my ammonia. Ammonia becomes ammonium ion. So NH3 is becoming NH4 positive, and these two are only different by an H positive. So this time the NH3 is accepting a proton or hydrogen ion. It is increasing by H positive. So this is my Bronsted Lowry base. On the opposite side of reaction, we have our conjugate acid and base. So the opposite partner for each one will have the opposite role. H2PO4 1 negative will gain an H positive coming back in the reverse reaction. So that tells me this is the conjugate base. And the NH4 positive will donate a hydrogen, lose a hydrogen as it becomes NH3. So this is the conjugate acid. So my first conjugate acid-base pair, conjugate acid-base pairs are on opposite sides of reaction, are my H3PO4 and H2PO4 negative. My other conjugate acid-base pair is NH3 and NH4 plus. I always have my Bronsted Lowry acid and base on the left. My conjugate acid and base are on the right, and the conjugate acid-base pairs exist across the reaction.